Welcome to the Technology Addicts podcast, powered by Avnet Abacus. The core idea behind the all-electric society is to power as many areas of our society as possible with electricity. And crucially, that electricity should come from renewable sources, minimizing our reliance on fossil fuels and the emission of greenhouse gases that drive climate change. In Europe, this shift is already underway, alongside some 6,000 large power stations. Hundreds of thousands of wind and photovoltaic systems are feeding electricity into the grid. But transforming our energy system in this way brings major challenges, especially when it comes to stabilizing the power grid. To address this, the VDE, Germany's Association for Electrical, Electronic, and Information Technologies, has published a new background paper on grid stability. In today's podcast, we'll discuss the paper's key takeaways, the implications of electrification for energy grids, how the grid needs to be restructured, and the feasibility of an all-electric society. And we're very pleased to have a proven expert here to talk about this with us. So hello, Professor Jutta Hansen.
Good morning.
It's great to have you here in the studio. So grid stability made headlines in April when large parts of Spain and Portugal experienced a power outage. Now, should we expect such outages to become more common in an all-electric society?
I do not think that we will end up in an all-electric society, but in a more electric society. But the network itself can be fed or will be fed by 100% of renewable energies. And our intention of the paper was that we describe how we can enable stable operation for networks like this.
Now, Professor Hansen, you studied general electrical engineering. You worked in industry on transmission and industrial networks, and you've been a professor and head of the Department of Electrical Energy Supply using renewable energies at TU Darmstadt since 2011. I have to ask, what do you find so fascinating about energy grids that you've dedicated so much of your career and your time to them?
It sounds awful. Do I have to speak about my age? So that's what I find so fascinating with the electrical grids is that we have to investigate the system behavior. So we do not investigate the components within the network, but how do they cooperate? This is some mathematical modeling, and this I really like. And I am in a lot of committees because I want to make clear the position of the electrical engineers. Because sometimes it gets forgotten that these are the engineers who have to build the network and not the economics.
That's great. It's amazing. It's fascinating. The future is electric, which is a slogan often associated with the all-electric society. But nowadays, sales of electric vehicles and heat pumps are faltering. So is the future really electric? Is electrification truly without alternative?
The electricity will be one heart of the future energy system. At the moment, we have 15 to 20% of the primary energy, so of the energy we use here in Germany, is used for electricity, but it is only 15 to 20%. I do not think that all the energy will be made out of electricity in the future. It will be one big component, but the big task will be to connect all the energy sectors to have one energy system. This will be different. Just think about your household at home. In the past, you had some heating, you had the electricity, and for filling up the car with fuel, you went to the filling station. In the future, you probably sit at home, you have the heating made by electricity, you have electricity itself, of course, and the cars who are filled up or they are charged in the garage. So this is different. So this will be the big task, and electricity is one fundamental part out of that, but we need some other energy resources.
And what role does electrification actually play in achieving a climate-neutral future?
We often talk about renewables if we talk about reaching the climate goals, but we have to look at the whole chain, coming from the production, so electrical energy production, going to the consumption. And the production, we talk about the renewables, but the consumption, that we do not investigate so often. So what happened with all our industrial areas, processes, production, cement, concrete, what are we doing there? What are the alternatives over there? And also, if we talk about the transport sector, then we talk about electrical cars. But seldom we talk about planes, we talk about trains, we talk about ships. And we have to investigate all of those. And we have to investigate those, we have to electrify, and we have to find other solutions. So other solutions which are not dealing with electricity are welcome. And I hope we will find some of them.
So yeah, one part of it is all about changing energy sources, but how important is the more efficient use of energy in this context?
It's one of the biggest points within the whole chain because everything we do not use, we do not have to produce. Quite simple.
That makes a lot of sense. So if the goal of climate neutrality feels too abstract for some, what are the tangible benefits of the all-electric society for end users, whether they're industrial enterprises or private households?
That's a very good question. So, how to answer that one for everyone at home? I am convinced that fossils will get rare and they will get more expensive. So, that is one topic. The other topic is we can be independent of other countries, of other fossils. And this, at the moment, during this period in the world, is very, very important. So, these are two general arguments to discuss with or to give. We already spoke about the industrial areas that we have processes there where we have to be climate neutral, but of course they should be in the position to enable this one. So there should be a market for that one. And there is another point where I still believe in. I would like Germany to be the world master within the exporting the energy transition. So that would be a good point. And within the household, at the moment, it is already like this, that if you spend your money within PVs, batteries and heat pumps, you can save money. So this is quite clear.
That's quite convincing. So do we already have all the technologies we need for this transition?
Yes, we already have all the technologies we need. Some of them are still in the pilot phase, so we really have to experience how it works in reality, and that has to be done. And we should never stop to find new ideas, because this is the world we are living in at the moment. But what happens within 20 years? So I am convinced we will find more possibilities and we should find more of them and bring it into the network. One example is geothermal energy. So we have to exploit, we have to find out something more. The usage of hydrogen. We want to use hydrogen, but at the moment we are not there that we can really do that one. So we really have to find other solutions. So do not stop, but we should not say we have to wait for something to start.
Aside from the technologies, what else is required to realize the all-electric society? So beyond technical solutions, what contributions would you need from policymakers, the EU, or standardization bodies, for example?
That's the very difficult question, because what do we need? Let's put it like this. We have to enable the transition. So that's what we need are clear and stable routes. We do not have to change our goals from time to time because we now have another idea, a new idea. That should not happen. So this is the environment we need from all the other parties playing within the game. And always in Germany, we have to state we should not get lost due to bureaucracy. So that is one topic which we should have in mind. And we have to prove, even if we are doing our research, then we have to find out whether it works as we intended the things to work. So we need the environment for that one. And we also need standards for that one because it is important. But of course, we have to improve those standards. And that is what we see at the moment, that we have to adjust them very, very often. Because now that started in a positive sense. That what we reached is a very, very high share of renewables within the network. So this is very impressive what happened within Germany. And it is clear that the standards which we made 20 years ago, they are not valid. They are not fitting to those new share of renewables within the network. Therefore, we have to adapt them. And that is what we are doing. And that what we forget from time to time is that, of course, we need the acceptance of the society. If we want to build new overhead lines, and then, of course, people are affected, and then we should explain why we need them. We take them into the discussion, then that is what is done in Germany. So we need a lot of support to get the transition enabled.
Okay, and the VDE is a German association, so how do the conditions and measures in Germany differ from those in the rest of Europe or even globally?
That's what I already said, is that we have a high share of renewable energies within Germany. So this is very positive. This is what we already reached. And we reach it by improving the technology which we use, by changing the technology. So we have DC transmissions embedded in the German network. This is quite new, and this is what we already enabled. We have offshore wind farms which are connected They are very far from the coast, and we manage to have the energy coming from the sea to the coast. So this is very, very positive. What we also have is the research in Germany dealing with that one. It is that I said we want to be the champions with the transition, and here we really spend a lot of effort already in the transition, and that you remark. But we still have the task to bring it from the pilot phase to the network.
And what is the VDE, which is, again, Germany's Association for Electrical, Electronic, and Information Technology? What is the VDE doing to support the transition to an all-electric society?
The VDE connects the experts, the electrical engineers, and what is the mission behind to connecting those experts. What we want to do, we want to work in committees with the experts to find a solution for the new energy system. And we already said that it is an integrated energy system where we have to investigate all of the energy sectors like heat. We have to connect it with the gas. We have to connect it with the electrical energy. And there we have the experts working together so that they can exchange and that we find an optimal solution. But of course, we also want to inform the society. That's the reason why I'm here. And also the politics, and to bring in the ideas behind the electrical network. And one big task which is made for the future, we have to find talents for the future, so young talent, and this is where we build a platform that they can connect and find each other.
So we're talking about networks and connectivity and so on. How important are digitalization and automation in the context of the all-electric society?
If we compare the networks of the past with that what happens in the future, then we see that we have a very complex new structure. We have a lot of actors playing now the game, and in the past there were only a few big power plants and they brought the power to the customers. That's it. Now we have renewable energy everywhere on all voltage levels, a lot of actors behind that one, and renewables, they are volatile. So that what we have to find are some flexibilities. So we have to combine it because we always need the balance between production and consumption. And therefore we need flexibilities in forms of a battery, or we build some gas or something. This is what we have to manage. And if you now ask, do we need digitalization? Yes, of course, because we have to find out what is the state of our network. So is the current too high? Is the voltage in the ranges where we need it? So we have to measure a lot of things. And this is the first big point. And we need also automatic reactions if something goes wrong. Because that's what we said, that we have the new network with the renewables. So what happened is the network gets faster and it gets weaker. What does that mean? In former times, we had the big fossil power plants, and that's what they did. They have a big inertia. So it takes a time until they react. Now we have the power electronics feeding the PV, so the photovoltaics, into the network, and this is very fast. They can react very, very fast, but they do not have the inertia. They are too fast for us at the moment, so we have to find solution, and this has to be done automatically. So this is what we intend to do, and this is the big topic behind the paper which we wrote. What goes wrong with the stability, or do we have the stability? What do we have to ensure to enable stability? So we need the automatic reaction, but this is what we already have within the network. So this is not new. And if we talk about digitalization and then what we have to do, I want to formulate it different in a positive way, because it is also a degree of freedom. Because if we have digitalization within the network, if we have automatic control, then we can enable new functionalities. And this is perfect. So we take it also as a chance.
Okay, and what does the all-electric society mean for the electricity grids themselves? So particularly within the EU, do they need to simply be expanded, or do they also require fundamental updates?
We should not call it expanding the network, because that's what we do. I call it paradigm shift, because we said that we change everything. We have the chain again from the production to the consumption. The production is now made out of renewables. We have the transmission with new technologies. We have the consumption, which is not a pure consumption. It is also a production, because we have a lot of consumers which have their own productions within their household. So we change everything. Even the renewables, they have the volatile aspect. So keeping the balance between production and consumption gets more complicated. And this is what we said, the network is weaker and faster, and it is more complex. So everything changes, therefore the network also has to change.
Why exactly is the European power grid becoming more vulnerable to disruptions as the share of renewable energy sources increases?
In the past, we had only a few big power plants bringing the power to the customer, and it was quite clear how it works. Now we have a complex network with a lot of actors, and you have to find a solution. You have to find the operating point, and it gets more complicated. So this is what we have to do, and we have to find those flexibilities which we have to combine with the production that we have the balance. So the task is bigger at the moment, and this is what we have to manage.
What are some of the new technical solutions to address the complex interplay between power electronics, long transmission distances, and decentralized generation?
The renewables have a high share now in the network for the production, electrical energy production. So they have to take over a new role of the conventional power plants which we had in the past. And that means where are the technical solutions? We need a lot of them. So start with a volatile operation of the renewables. So we have to find a balance. We have to find batteries. We have to find hydrogen electrolyzers because we need also molecules to transport the energy to the right places. So we need energy management solutions, so find solutions not only for single households, but for a quarter where people live. So how can we balance within these quarters? We also have to manage long distances. As you said, the transmission, the way from the production to the customer is not shorter. Even if some people tell it is so local. No, we also have offshore wind and we need the offshore wind and we have to transmit. So we need new technologies for that one. And we spoke about HVDC transmission systems. So we find a new solution how to transmit because that what we have at the moment, that what you see on the towers is not really working for those long distances we have at the moment. And then, of course, we talk about the future and we talk about what happens if we not only have DC connections, so from point A to point B, but also some networks which are overlaid network to the AC network level. So really new technologies. And you see a lot of innovations are around. And we said one very major point is we spoke about the weak network. So it is not so stiff. So if something changes within the network, it goes faster at the moment. And how can we manage that one? We have to fasten up the control. So we have to change the control. And this is a new principle which we now prove that it works. So the consequence is that we can operate the network with 100% of renewables. Because at the moment, this is not possible. This is why we ask for some new power plants, for example, dealing with gas, because these are the power plants which still have their inertia. So that's what we need for the slow network.
And that brings us right to the next question, which is how can grids and control centers become more resilient? And what role, again, do digitalization and automation play in that process?
Yeah, we have a lot of possibilities. We have a lot of degree of freedoms, but we have to have them in mind for all the cases which we have within the network for 8,760 hours per year. So how to manage? So that what we need is a fallback level. So what happens if something in the network goes wrong with all the control, with all the automation which we have inside? Then we have to find a level where we say, okay, it is not the best level, not the best operating point, but we know the network keeps stable. So that is what we have to find. At least that we have to find. And there are a lot of more technical solutions we need for that one.
There seems to be quite a long list of innovations and upgrades that are required. So in your view, which is the most crucial area that has to be prioritized in terms of investments?
I would like to see that we can use all the renewable energy which we have already installed in the network. Therefore, I think infrastructure, so network, building up the network and creating flexibilities is the most important point. Because then we can keep the balance if we have sufficient number of batteries within the network. If we combine that one with the gas sector, then we can really use that one. If we can make heat out of the electricity, if it is produced, then we can use that one. And that we have to do because we should use all the energy which we have installed as power. And that what I also think is that we should continue and improve the integrated planning of the energy system. So to find what is needed from the gas sector and what is needed from the electricity sector. This is one example. And then we have to combine the plannings, because it does not help if we have some electrolyzers which are located at the wrong places in the electrical network, because then we have to build up more electrical network, even if we intend to have help for the electrical network. So that one we have to combine, and I would say these are the two very important topics at the moment.
What does the all-electric society imply at the component level, for instance, in terms of sensor technology, communication systems, cabling, passive components, and so on?
The components which we would like to bring into the network should be environmental friendly too. And this is one very big task at the moment. So what is all with the discussion of PFAS chemicals, which we have the SF6 discussion. So we have to find new devices, for example, switchgears, substations, cables, and we have to get rid of those elements. And at the moment, this is one big task which we have to investigate to find components for the network.
Now, looking ahead, will we reach an all-electric society? And if so, what time frame do you think is realistic for that to happen?
It should not be all electric, as we said before, but it will be more electric, and we will have one heart, which is the electrical network. And that's what I think for the transition process, which is very important. We should not always change the goals. And therefore, I stay with the goal that we want to be climate neutral in 2045, but we should not lose the industry, because this is probably one point which got lost in the past. We were too fast, but we should stay with the goal and not change it.
With that, I'd like to thank Professor Hansen for joining us for this interview, which is part of the new Focus magazine on the All-Electric Society. So thank you so much for being with us. We'd also like to thank all of our listeners for joining us today. And if you'd like to get in touch with Professor Hansen, you can reach out to her. You'll find her contact information and more about the topics we covered in the show notes. And there, you'll also find a link to access the full Focus magazine, which will give you an exciting deep dive into many more aspects of the All-Electric Society and the technologies that enable it.